The video presents Geomatys' work on the issue of marine submersion for Singapore. As Singapore is surrounded by the ocean, our demonstrator allows to analyze and visualize the impact of rising sea levels on the country. This rising sea level can be caused by various phenomena such as global warming, storms, and so anticipate the risks by installing protection on the coast to avoid this phenomenon. The first goal of this project is to modelize elevation and bathymetric data of specific Singapore area and ocean based on local datum. With elevation 3D model and ocean, the main goal of this project is to represent the footprints of water spread in the land with different variation of sea heights, based on the rising of the ocean level. This simulation is very important to represent the flood area on the land and anticipate future infrastructure to contain the risks based on an overall rise in sea levels. For this project, we use Geomatys Digital Twin product based on following technologies: Unreal Engine for the game engine rendering, Cesium for Unreal to display different kinds of elevation data by using quantized mesh format, and raster images to wrap realistic texture. Playground for Unreal, that is Geomatys library to represent, for example, currents, winds, clouds, and ocean. And finally, Examine Server, that is a geospatial platform for complex data integration processing based on OGC standards. The first step is data injection in Geodatalake Server. For the terrain, we use SRTM with 1 arc-second resolution and JEPCO dataset for the bathymetry. For Singapore area, defined by Singapore Authority, we use terrain and bathymetric dataset format provided by SLA and MPA. We use CityGML building dataset provided by Authority converted in 3D tiles format. We also use Sentinel-2 data for raster overlay. Data injection and CityGML conversion are realized by OpenAPI calling to store dataset in Datalake Server. Finally, a WPS calling is realized to aggregate all the data in a global product. To visualize 3D tiles in 3D demonstrator, the system is able to transform global elevation product in quantized mesh 3D mesh format by using WPS calling. To identify ocean and sea area, we use an extension of quantized 3D meshes format to generate water mask. Having 3D tiles data source is only one part of representation. The 3D tiles help us just to draw the elevation, but we need to drop another data source over the elevations, such as Sentinel-2 dataset exposed by server via WMS OGC standard. In this video sequence, we focus on dataset storage in Datalake Server. In Singapore dataset, we can find different kinds of data as images with high resolution, elevation and bathymetry data provided by the authority, and then city building is 3D tiles format. This new interface is focused on service instances for rendering, a specific WMS service with different kinds of data as Sentinel-2, elevation, and bathymetry in color map format. Another services are instanced to allow access to 3D terrain and building city models. The 3D demonstrator allows to have a global view of Earth. Users can be moved around the world at different heights. In this case of this project, we fly to the region of interest close to the coastline of Singapore. To highlight the bathymetry and elevation model, we wrap a color map to enhance elevation visualization. And on the land, we can see building city model. To have a realistic viewer, we dropped Sentinel-2 and orthographic images on the 3D terrain by using WMS services. The next video sequence is focused on building ocean level based on local datum and modelizing waves. Different parameters can be adjusted to represent different sea states like wind direction and speed. To simulate rising water levels, we can access and setting window which is used to set the water level and launch the process to calculate the footprint of water spread. In this example, we adjust the water level to 1 meter to analyze the impact on the land of Singapore. Now, we adjust the water level to 2 meters. The simulation helps us to have an approximate view on the severity of incidents such as the sea level rise for the country. In conclusion, as part of this project, we were able to use and test our solution based on your digital twin using OGC standards such as WMS and WPS. The system is mainly based on the simulated data, but in the short term, we intend to use the historical and forecast data to increase the realism of our demonstrator. This project has enabled us to add many enhancements and functionalities, improving the representation of oceanographic phenomena such as sea states and the implementation of algorithms for calculating the impact of rising sea level on the land. Geomatys would like to thank OGC and Singapore Authority for their trust.